Today we're going to cover SQL injection. Now, SQL injection is an exciting topic, and anyone that's involved in cybersecurity, software development, or database administration should make sure that they have a strong fundamental understanding of what SQL injection is and how it works. And for everyone else, it's still interesting and exciting to learn and know more about. So let's go ahead and get started. Before we dive too deep into the fun and exciting parts, I want to make sure that we've got the fundamentals of how databases actually work covered. If that is something that you're already familiar with, you can go ahead and skip ahead. For everyone else, let's go ahead and get started. All right, so let's start with the question, what are databases and why actually use them? Databases are a method to store and manage data. And this data, at least in the modern database, is predominantly text-based data, such as your first name, last name, an address, your social security number, credit card number, health records, etc. If you go to a doctor's office or to the hospital, they'll enter that information into their medical system, which that information will be retained in a database. Likewise, almost anywhere you go these days, any information that's being entered gets stored in a database. Now, it's not limited to only text data. I was just using that as an example, and that is the most common type of information that is stored in databases, but you can store other information as well. You can store pictures, x-rays, videos, or literally any other type of data that you can think of. So these records and the type of data will basically be stored in the database, where it can be manipulated and then retrieved, searched, and produced in certain formats. Now, the reason why we use databases is because they're the best and most efficient form that we have to store and organize large quantities of data. Eventually, maybe there will be a more efficient system than what we currently deem a structured database is, but for now, we're stuck with databases, and they've been around for a very, very long time. Some of the most common databases that we have out there is Microsoft SQL Server, Oracle, Postgre, and MySQL. Now, while these databases are all different, they fundamentally function very similarly. SQL, or SQL, stands for Structured Query Language, and it is the language that databases use to communicate. So when we have web applications and really any type of database-driven application, they need to be able to enter records into a database, update those records, manipulate the information in the database, and request specific records or a combination of records from that database. And to do that, we use a language called SQL or SQL, depending on what your preferences are. SQL injection is an attack in which SQL code is inserted or appended onto an application instead of the traditional standard user code and user entry that the application would expect. And then that SQL code is then passed on to the database that then executes the code and the commands. Simply put, web applications are sites that you can visit via your web browser. And these websites can be websites that allow for user input. They could be e-commerce sites that store products in a database, or these could be specific applications that are web-based that you can visit via a web browser, such as, for example, an accounting application. In either case, the common denominator for these web-based sites or applications is that the information that's entered is stored in a database somewhere. Why are web applications vulnerable to SQL injection? To better understand this, let's take a look at how they actually work. For this demonstration, let's say we have an e-commerce website. There's the front end of the website, what the visitors will see. Some of the site's features will include a user sign-up page, a user login page, a search bar, and an add to cart button. Now, when someone creates an account, the first name, last name, email address, and password are entered, and this information is forwarded to the database. The database then uses SQL commands to create the new records. The next time the user logs on to the e-commerce site, the database retrieves the username and password from the database and compares it to the one the visitor provided. If they are the same, the visitor is logged into the site. Suppose, for example, the visitor performs a search for dress shoes in the search bar of the e-commerce site. In that case, that search is forwarded to the database in the form of a SQL query, which it will search through the database for all entries that match the item dress shoes. And the e-commerce site will then display all of the items in the database found to be a match. Now, the database can be on the same server as the e-commerce site or on a different server. As long as the e-commerce site can connect to and communicate with the database, that is all that matters. As for the vulnerabilities, the e-commerce site expects the visitor to play nice and use the site as it was intended. If, however, the visitor sends SQL commands or appends SQL commands to the expected input, this can trick the site. The e-commerce site will pass the SQL commands on directly to the database for execution. Suppose the e-commerce site does not perform the proper validations of what the visitor enters. In that case, this will leave the site vulnerable to SQL injection attacks, and the intruder, pretending to be a normal visitor to the site, can now have his or her way with the backend database. There are essentially three types of SQL injection attacks commonly used. The first type is usually referred to as an in-band type, and that includes two techniques: error-based and union-based. Error-based SQL injection techniques rely on receiving an error message response from the actual database server. Union-based SQL injection techniques use the union SQL operator to combine results of two or more statements into a single result. The second type of technique is referred to as out of bound, and that exfiltrates data using a different channel than the request was made with. This is oftentimes a more complex attack that requires sufficient privileges on the database and on the network. This attack is seen less frequently due to the additional complexity involved. Last but not least, we have what's called inference or blind-based. And this type of SQL injection works by submitting a SQL query to the database and forcing a response action. This method is called blind because the database response is not returned to the attacker, and therefore the response is not seen by the attacker, and he or she must anticipate what's going to happen. And there's two variants of a blind-based attack. One is using a Boolean-based operator, and the other one is time-based, where a certain time delay is set. You can either manually test for SQL injection vulnerabilities or use a tool such as SQL Map that will automate the process. There are some benefits and drawbacks to either one of the approaches, be it the manual one or the automated one, but we won't have enough time to cover it in this particular video here. But to be clear, understand that in most real-life data breach attacks that you'll see out there that involve SQL injections, there is going to be an automated approach using SQL Map or a similar tool to speed up the process. Also, when investigating any real-world intrusion and system compromise that involves SQL injection, the most common approach is going to be to use error-based SQL injection techniques to determine if a database application is vulnerable to SQL injection, and also to enumerate as much information as possible about the database, such as what type of database it is, if it's a Microsoft SQL Server or if it's a MySQL database, what version of the database, as well as try to use error codes to enumerate more information about the database structure. Now, what you can do with a successful SQL injection will depend on a few factors, but in most cases and almost always you'll be able to read content of the database, including usernames, passwords, and other sensitive records. Now, in most cases, you'll also be able to modify the database by appending records, deleting tables, and even being able to delete an entire database. And some of the more advanced techniques will also allow you to write directly to the file system and send OS commands. And that's regardless if it's a Windows or a Linux-based server. And at that point, you pretty much have a full system compromise, and what you can do at that point is only going to be limited based on the limits of your creativity.
When it comes down to preventing SQL injection, there are essentially two methods of defense. The first one is to block any strings or input that match typical SQL injection conditions. This can be done with a web application firewall or even with a proxy server. Note, this can help prevent the most common SQL injection attempts. However, it may not catch every variation, especially if the attacker gets creative. Furthermore, it does not solve the underlying vulnerabilities. The second approach is to code your application with security in mind. Prevent multiple input statements, use placeholders instead of variable interpolations, and make sure to validate every user input. If possible, use an allow list for user input and block everything else. I know it's not always feasible, but when it is, it's a great solution.
I hope the short video on SQL injection attacks was informative, and as always, be safe and be secure.